All right, we haven't done this in a long while, but we're going to do some math. I'm hoping I can still remember how to do it. All right, let's look at number one. Well, I guess I'll do a quick introduction here. First off, this is probably going to be a no editor. We're just chilling, or I'm just doing this really for myself. I just want to do some math. I'm not streaming it or anything. This is SAT Practice Test 4. Now, I've definitely done a test before that was titled SAT Practice Test 4, but I don't recognize these questions. Now, it has been like 3 or 4 years since I've done an SAT question, which is very sad to say. But we're about to end that streak right now. Number one, a group of students voted on 5 after-school activities. The bar graph shows the number of students who voted for each of these activities. How many chose activity 3? Now, I will say I glanced through this, and I was kind of disappointed about how easy these seemed. Like, this is just clearly 39, right? Like, this is where it's good that it's multiple choice, and clearly it's going to be multiple choice when you can't get an exact answer in between. There's only one answer in between 35 and 40, so the answer is B. Now, I'm going to check all my answers at the end, so make sure you check your answers too. If you're doing this in real life, to be honest, you should be checking your answers right now. And I would go check my answers right now, but I think I'd have to go find them somewhere. I don't know where they are. So we're just going to continue on. If you're doing this for real life, for real practice, you should check your answers after every one. But we're just doing this for fun. I don't even remember how to use Notability. Okay. Number 2. Plus, we don't need to check that answer. That's obviously right. Number 2. What percent of 300 is 75? Now, I kind of like these. Some people will tell you to do... Well, really, no. This is the way to do it. Read this, literally translate this to algebra. So, left to right, let's go, what percentage? What do we do in math when we don't know what something is and we want to solve for it? We call that X. So we're going to say X of. We don't really have to really know why. I feel like I couldn't even totally explain why. But we always are told of means multiply in math. So we'll do that. 300, that's just 300. Is, what do we mean if something is? If something is something, if X is 2, how do we write that? Equals. X equals 2. So is the same thing as equals, which I feel like should be emphasized with the same intensity as teachers say that of is multiply. I feel like I did when I was a teacher, but when I was a student, I feel like that was one of those things I kind of like, quote, discovered on my own. That of is multiply, is equals, the numbers are numbers, what or whatever the question word is X. And so literally all we do is we're just writing this as an equation. We're getting that 300 X equals 75. Divide both sides by 300. Now that might be tough. This is the no calculator section, right? Right? Use of a calculator is permitted. Never mind. This is the calculator section. Interesting. Okay. Well, we can get a calculator, but I was going to say we should definitely kind of recognize that that's 1/4. Right? Because 75 times 2 is 150, and 150 times 2 is 300. So that's just 1/4. That's 75 times 4. Cancel. Boom. Of course, we still have NumWorks here. Incredible stuff. I haven't used a NumWorks calculator in probably 3 years, but it's still over there in my slide over. All we would have to do if we wanted that was 75 divided by 300. And now you'll notice that none of these answers are... Whoops. Shoot, I don't remember how to use NumWorks. I thought this was supposed to be an easy graphing calculator. It is. Okay, 0.25. So you'll notice that none of these answers are actually 0.25. And some people try to deal with that by like putting 100 into the equation. I think we just ought to recognize that if it's percents, when we get that X is equal to 0.25, that's just 25%. And if you don't want to really remember that, just look at your answers. Which of those is close to 25%? There's only one of them. Or which of those is close to 0.25? 25%. Okay. 3. I mean, we're just going to solve for X. If we have this I feel like it's kind of silly we're using calculators for this. But I guess we almost have to. No, you don't have to. You shouldn't use a calculator for this. But you can. I mean, actually, I guess the real answer is you should just use a calculator for this. You should just say that we're going to do 35 times Well, you get it wrong if you did that. Maybe that's why you shouldn't use a calculator. 25 times 36 equals 900. We're going to take the square root of that answer, and we're going to get that the answer is 30. But you shouldn't use a calculator for this. That is quite lame. Shoot. There needs to be a better thing for that. I never want to half screen this. Okay. What we really should do is that we have 25 times 36 here, and when we square root both sides, this just cancels to 5, and this cancels to 36. Or this cancels to 6. So we get that x equals 5 times 6, which is 30. So x equals 30. I got to figure out my handwriting again. I haven't even written on an iPad. I haven't done any of this stuff in like 3 years. Okay. So here we got another translation thing. 3 more than 8 times the number x is equal to 83. Which equation represents this situation? Okay. I want to start from just the end, because we got is equal. You don't even have to say equal there. You could just say is 83. So we're definitely going to have an equals 83 at the end. Let's do some strategies. It's definitely not that one. So then we got 3 more than 8 times the number x. 3 more than 8. This is ambiguous, isn't it? Because you could say 3 more than 8. 3 more than 8. Yeah. You could say 3 more than 8, which is 3 plus 8, times the number x is equal to 83. Or you could say 3 more than 8 times the number x is equal to 83. I feel like those are both valid options. Now, which of those options is actually available to us? A looks close, but is clearly not it. So the answer would be they flipped it around, and it's D. The answer is D. Okay. Not bad. Now, what's the goal here? We're probably not going to finish this whole section. How long do you need for this section? It was actually like 25 minutes, wasn't it? Oh, no, it's 27 questions. You probably get an hour for this section. I don't know. We're going on. Number 5. This is always one of my favorite questions. Hannah deposited a fixed amount into her bank account each month. The function f of t equals 100 plus 25t gives the amount in dollars in Hannah's bank account after t monthly deposits. Yeah. What is the best interpretation of 25? So yeah, here what I always would try to harp about, you got to recognize this function here. Well, at least I think the best way to represent this function, to kind of make it like a systematic thing, is to think about how this is like y equals mx plus b. This is the mx part, because the x is the variable, and then this is the b. So here with the slope m, that's our rate of change. How did that always go? It's how much x changes every time y changes by 1. So in this case, we're saying that x, which is the dollars per account, changes by 25 every time the y, no, the x is the t. No, rise over run. I said slope totally wrong. I am very rusty. It's how much y changes every time x changes by 1. So x is t in this case. So every time the t changes by 1, every 1 month, they're putting $25 into the bank account. So every month she's putting in $25, or the balance increases by $25 every month. What are these answer options? With each monthly deposit, the amount in Hannah's bank account is increased by $25. I mean, that's the right answer right there, clearly. We don't need to read the rest. In real life, you would just move on now. But let's see. Before Hannah made any deposits, the amount in her bank account was $25. No, I was about to mention that, actually. That's that right there. That's the y-intercept. As you think about the y-intercept is whatever y is equal to when x is equal to 0. And I know that sounds so simple, but that's such a key thing. And anytime you're trying to find the y-intercept, you find the y-intercept a lot in math. That's such a key thing, that the y-intercept is whatever y is equal to when x is equal to 0. And so in this real world situation, x is t. So when the time is equal to 0, in other words, at the beginning, that's how much y is. That's how much is in her account. 100. So she started this account with $100, and she's putting $25 in every single time. And every time you see a slope, every single month. And whenever you see an equation like this, you know that like that's always the idea. Like I'm just glancing over, I'm seeing these. If this was representing anything, it would be starting at 29 and it's going up by 3 every whatever interval. If this was negative, it'd be going down by 3. So always say, we're probably going to use that same idea here on number 8. Anyway, we're still on number 5. We're on number 5. It feels like we've been doing math for so long. We're on number 5. All right. So C, after one monthly deposit, the amount in Hannah's bank account is 25. No, that would be if it was F of 1 after 1 month or one deposit, because that's what it is actually. Well, T, monthly deposits. So it could be every deposit or every month. If we did F of 1, that's how much money would be in her account after one deposit. Hannah made a total of 25 deposits. That's nothing. Just get that out of there. I don't know what that is. So really, I would say kind of your tip is anytime there's a question where you're interpreting like this, it's either going to be the answer that's like A or the answer that's like B. Because A is the slope, B is the y-intercept. And that like exact question comes up a lot. I had a whole section in my binder like that. All right, 6. A customer spent $27 to purchase oranges at $3 per pound. How many pounds of oranges did the customer spend? Well, what's jumping out to me is 27 divided by 3. Also, how is this a not multiple choice question in the middle of all these multiple choice questions? I am very unfamiliar with the SAT because it's given online now. Do they even do a paper version or is it always online? Surely they do a paper version still. All right, a customer spent $27 to purchase oranges at $3 per pound. So this is actually like my chemistry dimensional analysis idea that I like to always think about. Is that I'm like, we have $27. That's the thing that we know. We want to translate that to pounds. We want to cancel out the dollars. And we know that if we have $3 and we have 1 pound, we know those are equal, right? It's $1, it's $3 per pound. And if we do that, the dollar signs are canceling out. And that shows us the math that we need to do. 27 divided by 3. So the answer is 9. My handwriting is incredibly bad. I really have to work on that again. And we'll start right here. Nazir bought 9 storage bins that were each the same price. He used a coupon for $63 off the entire purchase. What an incredible coupon, $63 off. The cost of the entire purchase after using the coupon was $27. What was the original price? All right, so we'll just kind of work backwards. We'll say if we have 27... I did just drink like a whole pot of coffee. Maybe that's the problem. 27, the cost of the entire purchase after using the coupon was $27. So let's add back on that coupon. Let's add on that $63 off coupon that he just happened to have. And so that will get how much it should have been in the originally. Luckily, those numbers add together nicely and get 90. So he should have been spending $90 for his 9 storage bins, which means if we divide that by 9, that's supposed to be $10 per storage bin. Very good. 8. For the linear function, the table shows 3 values of x and their corresponding values of f of x. Which of the following equation defines? Okay, yeah, we're going to use the exact same ideas that we used before. So let's remember, y-intercept. It is when x equals 0. That's just always the y-intercept. So the y-intercept in this case is 29. So we automatically take off b because there the y-intercept is 32. And this one because the y-intercept is 35. And then we just have to look at the slope. And then remember the slope, this table is actually incredible for that too. The slope, every time x increases by 1, this increases by 3. And that's just the definition of the slope right there. So we see that it's A. All right, similar triangles. This one does look a little familiar, but all similar triangle problems are going to look the same. So they have similar drawings. Similar drawings. Okay, right triangles are similar, where P corresponds to S, obviously. If the measure of Q is 18, what is the measure of S? Okay, so all it really could just say they're congruent, they're similar, all the same thing to us, and similar triangles, all angles are the same. That's like the definition of being similar. And we know this is 90, so we just have to figure out what P is by knowing that all the angles in a triangle add up to 180. And so if we take away that 90, we know that these angles add together to get 90. What do you add to 18 to get 90? 72, right? So if that angle is 72, we know that this angle also has to be 72. B. What's our process of elimination? I mean, we know it's not that for sure. And what, 82 is just for people who try to do the math in their head and don't carry the 1? That's brutal. That's brutal. And see, that's why I think if the SAT is really doing things properly, it should almost be like this is half credit. I don't know if they actually do that. I feel like maybe they do and just don't tell us. I don't know if they'd have to tell us. But, like, you should kind of get half credit if you do 82. Except for, honestly, you should almost get half credit. Well, no, it's obviously not 18. You should say it's obviously not 18. Oh, well, just musing about the SAT. It has all sorts of problems, of course, as I'm sure you know. All right, so the scatter plot. So a lot of people, I mean, line best fit, linear model. I mean, even if you don't know how to do this, just think we're roughly trying to draw a line down the middle here. We're obviously not going to calculate it exactly because that's a crazy formula. And maybe now that you can use a graphing calculator, I mean, you could get trapped here. You could go in there and type in all these points into your graphing calculator and you can get the exact equation of the line. And the funny thing is it's still not going to match this exactly because there's all these points in the middle and then you still might get tripped up. But that's definitely not what you want to do. You want to eyeball the y-intercept. You want to eyeball the slope, just like we do on all the problems that involve it. I mean, that's basically, we had basically the exact same question here. It was just instead of a graph, they gave us a table. So what's the y-intercept roughly? I would say it's roughly 10. And then we look at the options and we see, well, there is no option where it's 10, but there is an option where it's 9.4. So it's either C or D. Cross out A and B. And then we look at the difference now. Because we could try to calculate the slope. I'm really glad that we don't have to try to calculate the slope. We look at how this one is positive and this one is negative. And we say, what is the slope of this line? Well, left to right. Graphs are always left to right. It's going down. So it's a negative slope. So it has to be D. $11. The given equation. So the reason I paused there first off was because I'm just looking at this question first off and I'm thinking, what is this question going to ask? I'm trying to anticipate what the question is going to ask. I think that's a good strategy. And it looks very similar to this number 5 is what I'm kind of guessing. So number 11, the given equation describes a relationship between the number of birds and the number of reptiles that can be cared for at a pet care business on any given day. If the business cares for 16 reptiles on a given day, how many birds can it care for? Okay, I should have known that it's not like that because there's 2 variables here. But anyway, interesting. Okay, okay, so this is just a plug in and solve, right? The business cares for 16 reptiles on a given day. We're just going to plug in 16 for R. And funnily enough, I can see what's already going to happen. 5 times 16, that's 80. So we're going to have 2.5b plus 5 times 16 equals 80. Now, how do I know that's 80 so well? Because there's a trick when you multiply by 5s. I'm going to think about this 16 as 2 times 8. So we have 5 times 2 times 8. That's 10 right there. So we really just have 10 times 8. So we have 80. And you can already see what's happening right here. This 80 is canceling out. And we're just then divide by 2.5. So B equals 0. They can't count for any birds. I feel like what they're trying to go for on that question is they're trying to say, are people going to accept the fact that the answer can be 0, that you can't care for 0 birds that day? Now, if it was negative birds, I would be worried. But 0 birds that day, yeah, that's just fair. All right. Before I read the question, I'm looking y-intercept. We can calculate the slope exactly here. So let's start with the y-intercept. That's always easiest to see. It's negative 8. They're all negative 8, so that actually doesn't help us. I feel like what they're almost trying to get at here to mess us up is the scale. Notice how the scale is not a square. So like if somebody was just trying to eyeball slopes, they're going to eyeball it wrong. We actually have to calculate it if we want to calculate it. But before we do that, we're going to notice, is it positive or negative? It's negative. So already we can cancel out these. And then, yeah, if this was a square graph, I'd be saying right now, notice that it's not like a 45-degree angle. So we know that it's not a slope of 1. But in this case, actually, it is a slope of 1. I feel like they're trying to get us here too. Because now you have to actually look, what is our rise over run? Now I did that backwards. But let's see. So it goes up by 2, and it goes over by 2. So the slope actually is 1. The slope is 2 over 2. It's 1, negative 1, because we can see that it's negative. So our slope is C. Our answer is C, because our slope is negative 1, and our y-intercept is negative 8. Man, these are lame problems, but I still have a lot to say about them. All right, this is one of my favorite math facts. Well, that's hard. It's not that good. If we have x over 8 equals 5 over 1, we can just flip over both sides of the equation. So we can just flip over both sides of the equation here if we imagine that 5 is 5 over 1. And if we were trying to solve for x, that obviously wouldn't be interesting in this case. But we're not. We're trying to solve for 8 over x. So 8 over x is just equal to 1/5. I mean, that's the answer right there. And that's actually a really good point to try to make here, is that a lot of people would try to do this by like multiplying both sides by 8 and getting that x is equal to 40. And then saying, okay, well, what's 8 over 40? Well, now let's cancel out the 8 and let's get that it's 1/5. And it's like, yeah, that's not that much slower. But when you're in this test, you need all the time you can get potentially. You might have some hard questions. They're going to be harder for you than they are for me. I'm a math teacher, so obviously they will be. And so knowing these little tricks, you see x over 8, what's 8 over x? Just flip it over. That 5 is 5 over 1, flip it over. The answer is just 1/5. Move on. You should be doing this way faster than I'm doing it, though. Currently. In real life, I mean, when I took the SAT, I took the SAT when I was the math teacher, when I was like actively a math teacher. And I got an 800 and I had so much time left on every section. All right. What is the solution to this? What is the value of y for this? Oh, now this kind of sucks. I mean, the other thing is you don't need to sit there in real life and try to figure out what's the fastest way to do it. You just need to do it. When I see this right away, I'm like, oh, I'm just going to subtract the equations. I mean, we need to know that, right? When you want to solve for systems of equations, you subtract the equations. So we're going to subtract these. We're going to get 18x equals 48 minus 72. Frankly, I know I can do that. But even in real life, I would type that into a calculator because that is just faster. Negative 24. So x is negative 24 over 18. Go ahead and simplify that. 12 over 9. Go ahead and simplify that. 4 over 3. That's another good tip that I think is just if you're trying to simplify a fraction, you don't need to do it all at once. You can do it step by step. I saw that 2 went into both 24 and 18. And I saw that 3 went into 12 and 9. So sure, that means that 6 goes into 24 and 18, but I didn't see that right away. So I took it one step at a time, and that's fine. And then the very, very, very important thing, I'm even going to investigate the color situation here. Ooh, I remember those colors. This is what we want, not this. So now that we know that x is equal to 4/3, we're going to actually find y. So let's try to choose the simplest equation. I would say it's the bottom equation. 6 times 4/3 plus y equals 72. Cancel. 2 times 4 is 8. Subtract 8 from both sides. 72 minus 8. 8 minus 2 is 6. 64. 64 is the actual answer. Now that leads to interesting discussion. Maybe it's a good policy. Let's do it. We're going to solve it again in a different colors. Let's do blue. To always just solve what they want us to solve for. Like, for example, we could have multiplied this bottom equation by 4. What do we get when we do that? I'm going to skinny this up a little bit. What do we get? To multiply it by 4, we get 24x plus 4y. 72 times 4, 288. Is then now when we subtract them, we get rid of the x instead of getting rid of the y. So if we subtract this blue equation from the top one, we're going to get negative 3y is equal to negative 240. And now we get a different answer for y. Spaghetti-O, what's going on here? What math did I do wrong? 72 times 4? Did I do that wrong? 288? No, I was right about that. Get out of here. I was right about that. Subtract that, you do get 240. You divide by -3, you get 80. Y equals 80. Did I do something wrong here? What did I do wrong in the first time then? I subtracted the two equations. 24 minus 6, that's 18. 18 divided by 24, that's definitely 4/3. So x is definitely 4/3. You plug in 4/3 into this times 6. So that becomes 2, that becomes 8. It's like I'm missing a negative somewhere, somehow, on one of these equations. Well, this is kind of embarrassing. I'm not even sure which way I'm doing it wrong. Where is the missing negative? Oh, I dropped the negative on the x here. This x is negative. This x is negative. So we should be here. This should be negative. So we should be getting -8 here. We should be adding 8 to both sides and getting that y is equal to 80. Yep. Okay. Well, I'm glad I did it the other way because I actually got it wrong. Now, when I took the SAT, I wasn't really expecting an 800, to be honest, because I do stuff like that sometimes. I don't think that's anything to be ashamed of. I mean, sure, it messes up your 100%, like when you're taking tests, but I don't think that's anything to be ashamed of, dropping a negative sign somewhere. I mean, it's clearly right there, and I just drop it in the next step. I was focused on simplifying the fraction. That is too bad, but at least I got the right answer in the end. Y equals 80. And I do think that's probably a better policy. Look at how easy that was, especially on this one. X was so hard to solve for. That maybe is a better policy, is just always solve for what you're actually trying to find, which is, in this case, is y. So eliminate the x. Don't try to eliminate the y. Don't do it the purple way. I mean, look how much purple work we did and look how little blue work we did. Just solve for what you want to solve for. I think that's a good tip that I'll stick with. All right. Should we do one more page? Or maybe one more problem? Let's do one more page. So I feel like we've talked a lot of stuff about here. All right, line T is in the xy plane has a slope of -1/3 and passes through the point y equals 10. Okay, well, this is a quick one. And we've covered this concept so many times today. We have a slope of -1/3. That's the m. That means we need a -1/3 here. That's only these. I mean, recognize that that's -1/3, or at least recognize that these are not -1/3. And then what's the y-intercept? Ooh, they don't tell us the y-intercept. It has the 0.9, 10. Well, frankly, I would tell you the y-intercept ain't 10. So it ain't this one. It's got to be D. I mean, that's your test-taking strategy tip to use. Because if the y-intercept is D, like the y-intercept is what the y value is when the x value is 0. And the y value is 10 when the x value is 9. So the y value can't really also be 10 when the x value is 0. So it's got to be something else. It's got to be D. I mean, that's the only option. We don't have to do it exactly. If you wanted to do it exactly for completion, I do feel compelled, is the point slope form, which is definitely very important, is this. Which I also feel like I must mention, if you don't know that formula, it literally just comes for how do you calculate slope? Y minus y1 over x minus x1. or just the y values, the difference in the y values over the difference in the x values. You cross multiply that, you just get this formula. And if you plug all that in, you got your negative slope of 1/3 x minus whatever the x value is they gave us equals y minus whatever the y value is they gave us. You distribute that 1/3. Let's make sure we get those negative signs right because we're distributing the negative. So that should be positive is y minus 10. Add 10 to both sides. Negative 1/3 x plus 13 equals y. Boom. Didn't need that, just to be clear. Make sure you're doing it quick when you're in real life. Okay, this one is just like the slope, except it's with exponentials. So when I look at this, this is like our y-intercept. Instead of adding, we're multiplying. Everything's going up a level for exponentials. Instead of adding, we're multiplying. And this is like our slope, because instead of multiplying, we're exponenting. Okay, so that function models the value in dollars of a certain bank account by the end of the year between those years, where X is the number of years after the starting year. Which of the following is the best interpretation of, okay, I thought that was like derivative for a second, of f of 5 is approximately equal to 243 in this context? Okay, so we don't even need to know that this is an exponential equation for that. We just need to say f of 5, so that's like when t equals 5, when time equals 5, which in this case, that's years after 1957. So that's that like in 1962, we had $243 in the account. That's really just dollars. Okay, $243 in the account. So let's read the options. The value of the bank account is estimated to be approximately $5 greater in 1962 than in 1957. Absolutely not. The value of the bank account is estimated to be approximately $243 in 1962. Well, that's exactly what we said. The value in dollars of the bank account is estimated to be approximately 5 times greater in 1962 than 1957. No, that's definitely not it. The value of the bank account is estimated to increase by approximately $243 every 5 years. No, that's definitely not it. If we're talking about f of 5, all that's saying is just plug in 5, which in this case is plug in the time. How much time has passed? Whatever you get is the answer to whatever they said the function represents, which in this case is the dollars. Okay, 17. For a certain rectangular region, the ratio of its length to width is 35 to 10. If the width of the rectangular region increases by 7 units, how much must the length change to maintain this ratio? Oh. I mean, I'm tempted to just say 7 units. This is something I'm not super familiar with. But let's really think about it. So, because I think that's really a lot of SAT questions, is you're not really supposed to be super familiar with it. You're supposed to kind of figure it out. For a certain rectangular region, the ratio of its length to width is 35 to 10. 35 to 10. If the width of the region increases by 7, how much should the length change to maintain this ratio? Okay, so we're trying to oh man. Wait. Don't we need to know like exact numbers here? Are they saying the width is 35 and the length is 10 or vice versa or whatever? Or are they saying it's a ratio? Because then it's increased by 7 units. The length is going to have to be more. I guess it's, well, okay. Process elimination here. We don't need to actually know this math or do this math when we start looking at the answers. We want to maintain the same ratio. We're not trying to maintain the same area, which is what I was kind of thinking about at first. We're trying to maintain the same ratio of length to width. So we know if we're going to increase the width, we're going to have to increase the length. So let's get these decreases out of here. And so then the only question is it also by 7 or is it by 24.5? Now, if we were looking at a square, if we made one side longer to still keep it a square, we had to make the other side the same amount longer, right? But if we're talking about a rectangle where one side is longer, they're increasing the width, which is the 10, by 7, they're going to have to increase this by more than 7 to keep it longer, right? If we increase them both by 7, that's going to change the ratio because one's already bigger than the other one. So we have to do it by an amount different than 7, which in this case is B. And I feel like I don't even want to waste time getting that the real way. They were nice enough with the answer choices to get that in process elimination. Okay, now this seems like it could be a fun question. Square P has a side length of X inches. Square Q has a perimeter that is 176 inches greater than the perimeter of P. The function f gives the area of square Q in square inches. What is of the following defines f? I stopped thinking at the end while I was reading there. All right. The function f. What is f? Is the area of square of Q. The area of Q. Square Q has a perimeter that is 176 inches greater than the perimeter of and we're looking for the area. Holy moly, this is a hard question, kind of. The square has a perimeter of 176. So we actually, maybe it's just hard because I don't memorize the formulas for the perimeter and area of square any different than I would the rectangle. The perimeter of a square is 4s. So right there we get like the side length, right? Well, we're going to say, all right, 4s is equal to, we're just translating the sentence. The square cube perimeter, that's 4s, is 176 greater than the perimeter of square P. Okay, call that SQ, call that SP. That's gross. Well, square P has a side length of X, actually. So this is just X. Also, it's 4, right? 4X. Okay. Let's rethink. Perimeter of square P. That's 4X. Square Q has a perimeter. So we're talking about the perimeter of square Q. That's 4 times the side length of Q. The side length of Q. So we're calling that S sub Q. The function gives the area of square Q. So we want the area. What is the area but S sub Q squared? So we want to find whatever S sub Q squared is. We're going to get S sub Q by itself. We're going to divide both sides by 4. So this, they're just going to cancel and just get X. 176 divided by 4. We could go to the calculator, but I'm going to flex my brain because I already got the answer. Is we're going to do 176 divided by 2, which is 180 divided by 2. Minus 2. I had it in my head. Now I'm messing up trying to say it out loud, but I think I was right in my head. 176 divided by 4. Oh, no, we just halved it. We said 76 divided by 2 was 38, plus half of 100, which is 50, is 88. So half of 76 is 88, so it's 88 divided by 2, which is 44. So this is 44. Also, it's right there in the equation. It is multiple choice. Right, so that was SQ equals that, and so now we want to square both sides to get that squared. So it's 44 plus X squared. Beautiful. And then, yeah, we look at the multiple choice, and it's all just different issues of the dividing by 4. You divide one by 4 but not the other, you got to divide both by 4. 18 is A. And you know what? I think we're going to call it a day there, because that'll give us some problems to do later, and we don't want to make too long a video. I didn't even set a timer. I know it's been 30 minutes already. Probably been more. But that was good. We'll check our answers next time. I'm pretty confident that all these answers are right. But, you know, that's the final last words. If you're doing this in real life, you should check your answers. We will next time. I just don't have the answers right now. I need to find them. All right. Peace out, y'all. That was fun.